Okay, so here is a couple old diploma questions once again. This one deals with isomers and in particularly isomers with line diagrams. So going on from with our organic chem unit, we have some information about our compound C10H16, and then there's a bunch of, and sometimes you don't know if it's helpful or not, but this rest of this doesn't really matter. But if you read it over, it does tell you about a reaction, so you might think it's going to be about an addition reaction or something along those lines, but it's not. All it's asking is which one of our 4 compounds given is not an isomer. So we want to look at our empirical formula, and we want all of these to match C10H16. The one that doesn't is not an isomer. So I'm going to start with ones that aren't as complicated as A. So let's look at the first one. So we know that every corner here is a carbon. So I'm just going to tick it off as I count. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be C10. And then when we get to hydrogens, with line diagrams, hydrogens are implied, and carbons can bond to 4 other atoms, so we want to see 4 lines. So it doesn't have to be in all directions. It could be the double or triple bond would still count as our line. So for instance, this carbon down here has 2 lines going away from it, so it can have 2 hydrogens attached. And then this one, same thing, 2, this one, same thing, 2. This carbon up here has 3 lines, so it could only have 1 more hydrogen. Up here, 3 lines, so 1 hydrogen, down here, 1 hydrogen, here, 1 hydrogen, and then like the other side, we have 2, 2, and 2. So let's go ahead and count them. So 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have our first isomer, so that's not going to be our answer because this is an isomer because we have the same values. Let's check this next one. So count your carbons first. So I'm going to start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have our 10 carbons. Now let's check our hydrogens. So down at this bottom one, again, looking for the 4 lines, I have 2. Here I have 1, 1, 1, 1, 1, 2, 2, 2, and 3. So counting that, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this one looks like we also have an isomer. Now, with letter C, remembering that if you have a benzene ring that we don't have a double, I don't know what that was supposed to be. We don't have a double bond everywhere. We have alternating double bonds. So why did I draw it with a circle? I will put a double bond there, a double bond here, a double bond here, and then I still have the other ones coming off. So if I wanted to count again my carbons, from this first one, I would have 1 hydrogen. Wait a minute. I would have 0 hydrogens here, 0 here. At this point down here, I'd have 1. Now 1, 1, 1. Up here, 2. Over here, 3, 2, and 3. So let's go ahead and count those. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Just want to double check that. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this looks like it's C10H14. Before I commit that C is our answer, I just want to check A. Now with triple bonds, they do form a linear structure, but there is a carbon right here and a carbon right here. And then we know we have the rest. So let's count our carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have C10. And let's now count our hydrogens. So at this very end, again, we want to see 4 lines. This carbon has 3, so it could fit 1 more hydrogen. Down here, we have 4, so no more. Over here, 2. This middle carbon, none, because it has 4 lines. Down at the bottom, we'd have 1. Up here, 1, 2, and 3. And then these ending ones would have 3. So let's go ahead and count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So looking at what we have, it looks like C is our answer. So just being careful, understanding those line diagrams and implying those hydrogens. Try to remember that every carbon gets 4 lines coming from it, and then you can add in your hydrogens to imply what's missing. Now, the other part is asking about how many carbon double bonds this compound here has. So that compound was your C10H16. Now I don't know exactly what it looks like, but I'm going to start drawing a diagram, just placing what we have. So I know that I have 10 carbons, and I'm just going to put them in a chain. So I have 5, 6, 7, 8, 9, 10. And now I'm going to start to place my hydrogens. I have 16 I need to place. So I'll just give 1 to each of these carbons. And that means I've placed 10. And I need 6 more to place. And so I'm just going to be symmetrical here. And you don't really have to be. Just put them anywhere you like. And we'll figure it out from there. So what I'm going to notice here, and I'm just going to move a couple in a moment, is that my N carbons are not happy, and it would be harder to draw a double bond there. So I'm just going to move what I had here with these hydrogens in the middle and put them on the end. So now this carbon is happy because it has 4. This is happy, it has 4. These ones in the middle are not happy, and these 2 at the end are happy because they're all bonded to 4 atoms. So to make them happy, we know that all of our carbons can bond to 1 more atom. So we'll add in some double bonds. So I now have a double bond between carbon 3 and 4. So this carbon is now happy, and I can't fit anymore. So now I'm looking at my next carbon fitting in a double bond. So that would make these 2 carbons happy. And then my last one here, this last carbon, what I'm looking at right here, is still not happy. And neither is this one. So 1 more double bond, and now these 2 are happy. And you can double check it and draw it out a little bit nicer, but now everything has 4 lines coming from it. We're still following this formula. Everything is happy, and that took 1, 2, 3 double bonds. So even if you draw this a different way, it's okay. Just place 10 carbons, add in your 16 hydrogens, and make everything happy by adding in some double bonds if needed. I hope, as always, that you found this helpful. If you did, please subscribe. And if there's any other video I can ever do for you, just let me know. Thank you for watching.